All right, Python developers, listen up. If you've ever built an API that has to talk to a database, you know the struggle I'm talking about. It's this classic problem that just leads to duplicated code, all sorts of bugs, and honestly, a ton of headaches. So today, we're going to break down that exact problem and look at a really brilliant solution, SQLModel. Okay, so let's get right into the mess. On one side, you've got your database models, right? Probably written with something awesome like SQL Alchemy, defining all your tables and columns. Then, over on the other side, you've got your API models, likely using Pydantic, to validate all the data coming in and going out. And the constant battle is making sure that every single little change in one model is perfectly, and I mean perfectly, mirrored in the other. It's just so tedious and, you know it, a huge source of bugs.
But what if you could just stop doing that? You know? What if you didn't need two separate sets of models to constantly worry about? Just imagine for a second if you could define your data's shape in just one place, with one single class for both your database and your API.
Well, that's exactly where SQLModel comes into the picture. It's a library that was designed specifically to solve this one problem by giving you a single, unified way to define all your data models.
Now, what's so brilliant about this is that SQLModel isn't just reinventing the wheel. Nope, it's built on the shoulders of giants. It combines the awesome data validation power of Pydantic with all the database magic of SQL Alchemy. And, get this, the best part? It was created by the same person who made FastAPI, so you know it's designed for a perfect, seamless integration. So, how does this actually work in practice? Let's get to the core of it, right? Let's see how SQLModel creates what we call a single source of truth. And here it is. This is the magic. A single Python class right here called Hero that defines everything. This is your database table schema and your API data model, all rolled into one beautiful, clean package. No more writing the same fields twice. Ever.
So let's break this down real quick. By inheriting from SQLModel and setting table equal to true, we're basically just telling it, hey, this class, it should also be a database table. Simple. We use standard Python typing, like optional, to say a value can be an integer or it can be none, which is perfect for things like an ID that the database is going to generate for us. And then we use field to add that extra database-specific info, like marking the ID as the primary key. It's just so clean and readable.
So, the model is defined. That's awesome. But how do we actually use it? Let's take a quick little tour of the 4 fundamental database operations: create, read, update, and delete, or as you probably know it, CRUD.
To create data, it's a super simple 4-step process. First, you just create instances of your hero class like any other normal Python object. Easy. Next, you create a database session, you add your new objects to it, and then finally, you commit the session to save everything to the database. Done.
Now, what is this session thing I keep mentioning? Well, a great way to think about it is like a shopping cart for your database. You can add new items, you can update existing ones, or you can mark stuff for deletion. It's all just temporary. Nothing becomes permanent, nothing actually hits the database until you're ready to check out by calling session.commit. Reading data is just as logical. Again, you start with a session, then you build a select statement to describe exactly what you want. In this case, maybe it's all the records from the hero table. You execute that statement, and then you fetch the results. It's really that straightforward.
And filtering? Oh, it's incredibly intuitive. To get every single hero, you just write select hero. But to find a specific hero, you just add a .where clause to your statement. The code reads almost like a sentence, which makes your intentions crystal clear. Okay, what about updating? Well, it's just as easy. You first read the object you want to change from the database. Then you just modify its attributes directly in Python, like setting the age here. And finally, you add that modified object back to the session and commit. SQLModel is smart enough to know this is an update, not a new entry. And to round out our CRUD tour, we have deletion. You probably know how this goes already, right? Just like updating, you fetch the record you want to get rid of, then you just pass that object to session.delete and commit your changes. And poof, the record is gone from the database, clean and final. So the crucial question is, why does all of this matter so much? This isn't just some minor improvement, you know? It's a fundamental shift in how you work with data in your Python applications. It really is a true game changer. Let's just summarize these advantages, because they're huge. You're writing significantly less code because you've completely eliminated that model duplication. This directly leads to way fewer bugs because it's literally impossible for your database and API models to fall out of sync.
You have one single class that acts as the single source of truth, making your code so much easier to read and maintain. And of course, like we said, it just integrates perfectly with Fast API.
So as we wrap up, let's just distill this all down to the one big idea that you should walk away with. What's the final takeaway from all this? Look, by combining your database and your API logic into one clean thing, SQLModel doesn't just save you some keystrokes. It eliminates an entire category of common bugs and mental overhead. It lets you focus on building great features, not on keeping data models in sync. And that brings us to a final question. If managing your data really becomes this simple, what are you going to build with all the time you save?